Okay, recording now. And actually, I'll use the Office program again, so I'll get that ready. Okay. That's not right. So let's just go through this quickly again. So A part 1 in number 6. What does the A? Oops. What does the A represent? It's the atomic mass. You're right. Which equals the number of protons plus number of neutrons. Okay. And then what is the Z? Atomic number, which equals the number of protons. 2 easy marks. Okay, and then part 3 is basically what's an isotope. So you know this from chemistry. I could say something like XAZ is an isotope of, let's call it X dash A dash Z dash. If, so for it to be an isotope, what needs to be the same and what needs to be different? Yeah, the proton numbers need to be the same. And they're different mass numbers. So you might call that like a formula definition. So it's an isotope if it's the same proton number, different, same atomic number, different atomic mass.
We can't explain it by words.
Oh yeah. Yeah, I'm trying to just do it quickly since I did this last time. Okay. Now B, the table. So would you be so kind as to call the, well actually let me first type in the title. So this is time in hours, not seconds. And this is log activity. And that's kilo becquerels. Okay. Yes, thank you. Right, the times are 0, 3, 6, 9, and 12, and then the activities.
9,
Yeah.
9, 6, 7, 9, 3, 6, 5. 9 goes 6.
Oh, 9. Oh, see, hang on, I have to fix one of my titles. And then 8, 7, 8, 3. Actually, that one, that's just the activity, yeah. That's the activity. And then here, this is what they want you to do, is log of the activity. So I'll just there we go. Now I have the marking scheme here, so let me just check that that's right. Oh, sorry, I skipped B. You're right. Let me do with B. Well, B was quite short. No, I don't think Excel is doing the log the way I wanted. Maybe if I just change this to ln. Yeah, there we go. That's fine. Yes, that's it. Okay. Sorry, you're right, Omar. I skipped the B. Okay. B. Now, 198, 79, what's AU? Are you just guessing, or?
Oh, sorry. Gold.
Gold, yes. AU is gold, isn't it? Yeah. Alright, so, what's happened here? The atomic number's gone up, so what type of radiation was this? Beta. So what does beta do? It releases an electron. And what happens here? Stays the same. It just gets a proton, loses a neutron. So, alright, now back to this one. Copy your table and calculate the log of the activity. That's done. Next one is to calculate the decay constant. Oh, so first I should do my graph. Now he only wants this and this. So insert, chart, scatter, that one, next, next. Next. Alright, so title is log activity versus time, and I should put in the units, but I won't bother here. X is the time in hours, and Y is the log activity. Kilo BQ. There we go. And in your graph paper you draw in the line, but since I've got this program open I can just do it automatically. There we go. Can you see this equation here? Actually I'll move it up there. There we go. So you get 4 marks for the graph, and then the lambda. Yes, okay. So next part is calculate the decay constant. So if I go back here now, I just drew a plot of what? On the y-axis was what? Log activity. But if you take out your formula book, the activity, I gave you the formula last time, it's, do you remember? A0 e power minus lambda t. Now, using my rules of log, what does this become? Log A0 minus lambda t. Very good, yeah. So if you look at this, you can see, hey, this is like the constant, and then what's this like? The slope, because, if I make it a bit clearer for you, it's like this. Y equals mx plus c. Wait, why are you so late? Why do you do this during my class? Hurry up and sit down. Do you understand how the lambda, or the minus lambda, is the slope? Now what is the slope here? It's minus 0.0107.
Can see?
Yeah. Seriously. You got that much space in front of it.
Hey Brandon, you can move a little bit because you were late.
No way further than
No trolling in class, okay? Alright. You all know trolling, don't you?
No.
Yeah? You all know what an internet troll is, don't you? Yeah? Okay. Now, look at the question. Do I need... Hey, what's wrong? Do I need to change the units? For C part 3, do I need to change the units? What do you think? No, because what does it say in the question? What does he give the unit in the question? He says in hours, yeah. It's for the next one I need to change it. So can you take... Can you please change this from hours into seconds. Now, just to, wait, just to be careful, the unit for this constant is, it's a bit like frequency, it's 1 over time. So it's 1 over hours. Okay? So, an hour is 3,600 seconds. So please take this and divide it by this. Please. Two point. Yep.
Times 10 to the power of -6.
6. Thank you. Now he wants the half-life, and there's a formula for half-life. It's given in the formula book. It is, if you look at the bottom of page 2, you get the half-life equals log 2 divided by your lambda. So what is that, please? That should be quite a big number.
Yeah.
What is it?
2333821.
23382.
No, 382.
Start again. 2.
82.88.
0.88 seconds. All right, so we'll just say 83 seconds. Fine. Now time for part 5. How much for this sample to reduce by 1/3? So do you remember the formula you could use? You want, how much do you want?
1/3.
Yeah, you want 33%, and what do you start with? 100%. E to the power of minus lambda, which is now in seconds. So I'll just write lambda here rather than writing that out, and t. Now what do? We divide, so we get 1 over 3 equals e minus lambda t. What's next? What do I do next? Yeah, let's just imagine the numbers in here for a lambda so I don't have to write it. So what do I put on both sides? Log, and what happens here? Cancel. So I get t, because this is minus lambda t, so I get t equals log 1 over 3 all over minus lambda, which is 2.97 times 10 to the -6, and you should get about, well, actually again, also very large.
369903.
What is it?
369903.127.
So that many seconds. Actually, that turns out to be about 103 hours. Okay, last part now of this. So he wants the A0 now, the initial number in it. Well, where can we get that? Easy peasy. Remember back here? I said the log A0, what's that like? That's a bit like the C, very good. So if I go to my graph, the C is 9.2, about. Okay? So I have log A0 equals 9.2. Well, let me give it a bit more. 9.209. But he wants the A0, so I should just do this. Not ln. Try again. E.
996.6.
So what is this?
9986.
No, just give me this.
9986.
E to the power of 9.209.
996.
Oh, sorry, 9986. Okay. Now that's the A0. But actually, sorry, I misread it. Yeah, that's the activity, the initial activity. But he wants the initial number of nuclei. So if you look at your formula, you can see at the bottom of page 2 again. You see at the top here? You have A equals lambda n. Yeah? We have the A, we have the lambda, and he wants the n. So simple formula now. Whoops. N equals A, or N0 equals A0 over lambda, which equals 9986 over, what's my lambda? 2.97 times 10 to the minus 6. Now please, actually, there's something I left out here. If you look at your data again, no, there we go. The unit is kilo. Kilo. Okay? So in fact, that A0 is 9,986 kilo. So I will get rid of the kilo by putting in this here. Just to be clear in people's head, the N represents, hey look here, the N represents how many atoms you have. Okay? The A represents how many atoms per second that you lose due to the decay. You got that? So I'll say that one more time. N is the number, how many nuclei you have, how many atoms you have. A is the activity, and the unit is BQ. And it means how many, the unit means how many nuclei you lose per second. So 1 BQ means you lose 1 nuclei per second. So that means it's decaying very quickly. So do we think the A should be big or small? Well, it depends on the material, yeah. Anyways, in this example, this, if just to write in, is kilo BQ. That's pretty big actually. Anyways, can you calculate this for me, please?
3.36.
Yep.
3.36 times 10 to the 12.
10 to the 12 nuclei or atoms. Yes?
And here says determine the time in hours.
Oh, did he say hours? Well, that's easily fixed. Just take this and divide it by 3,600. So that's seconds, and that equals, can you divide that number by 3,600 and we'll get hours?
103.
What is it?
102.75.
So 103 hours. Okay. Are we to do the same for the other one?
No, it doesn't.
No, it just says it for this one.
Yeah, for number 5.
Okay. Are you happy with that now? Yes?